you can talk. I mean, just don't say anything. Hey! So, welcome to Solving Physics Problems Live from D period, Pennsbury High School Honors Physics.
Yeah.
Anyways, here we go. We got Micah and Heidi are riding around the neighborhood on their scooters. Let me position this a little better. Why can't I do it? There we go. All right. Heidi is at rest when Micah passes her, moving at a constant speed of 0.32 meters per second. After 1.2 seconds, Heidi decides to chase after Micah, accelerating at 0.81 seconds. I forgot to write the question. When does Heidi catch Micah? And where? And where? When and where? How much time? Where? Okay. Well, let's draw a motion diagram because that's what we do. Heidi, nice constant velocity. We'll say Heidi and Micah, we're going to do them in different colors. Heidi and Micah are both, this is where they cross. This is my Micah, and this is my Heidi is in blue. Micah is moving at a constant velocity, so her spaces, she's going this way, are nice and even. Yes. Nice and even, and this is where they meet again. Heidi accelerates to get there. She's going to end up at that same place. 1, 2, 3, 4, 5. I always do 5. So not so far. A little bit further. 2, 3, 4, 5. That looks like acceleration, right? Gets further and further and further each second. Now some other information we know. We know this, we're going to call this x equals 0. That's x equals 0. And this place, I'm just going to call x final. And that's x0 for everybody. Everybody's right there. What's different is that this dot for Micah is time equals 0. So I might call that time initial for Micah. I wrote that a little bit small, but I got to remember that that's like time initial Micah. However, here, time initial Heidi is not at that same time. It's later. It's at 1.2 seconds. So Heidi's problem doesn't begin till 1.2 seconds later, Heidi's motion. So I'm making her first time at 1.2 seconds. Now when they meet here, this is the same time, right? This is time final, and it's the same. And this is the same. And that little identification that these first dots are not the same time is the big key to solving this problem. So I'm going to make a list of both girls. And I'm going to see how things pan out. What information I have, what I need, what's the same, what's related, that kind of thing. So we've got a Micah thing. Micah has a constant velocity, so I'm going to move it over here a little bit more so I have lots of space. Her initial velocity is the 0.32 meters per second. It's to the right, which is positive. I know the picture shows them going left. I forgot to flip it. Her velocity final is the same, 0.32 meters per second. Her initial position is what I called 0. Her final position is what I called x final. Her acceleration is 0. her change in time for Micah, and now this is where things are a little different than what I've done in the past. I've mentioned that time interval, change in time, is time final minus time initial. So I got to write that out. This is going to be time final for Micah minus time initial for Micah. And what those are, this is time final for my diagram, and time initial is 0. So that can be just said that her change in time for Micah is time final. And I go through that fast because I know what I'm doing. This is new to you. You would have to think through this a little more. But the diagram helps me tremendously. Then for Heidi, we've got her velocity initial of Heidi is 0. Her velocity final for Heidi, I don't know what that is. I don't know it. I don't want it. I got a good indication that that's something I should avoid. Her initial position is the same 0. Her final position is the same final position. Her acceleration for Heidi is 0.81 meters per second, which I'm sorry I made it that number because I wanted it, but it is. It is what it is. And her change in time, the change in time for Heidi, is her final time, which is the same, minus her initial, the initial for Heidi. And that means it's TF minus 1.2 is her change in time. So, looking this over, what do we know about things? Okay, we know a lot of stuff there. Don't know this, don't want it. Pretty sure I want to avoid that. No 0, 0. Don't know these, but they are the same, so that's valuable. I know the accelerations. The times, I don't know time final, but again, the TF is the same, so that's valuable. I can connect the two motions via position at the end and time at the end. So the thing that is left out there is this final velocity. So I want to avoid that. So I'll get an equation for both of these guys that doesn't have final velocity in it. Micah here, since she's 0 acceleration, she only has one thing she could be. For Micah, I've got this one equation. The final position is the initial position plus the velocity of Micah times the change in time for Micah. That's the only equation there is when there's no acceleration. It could be written different ways, but only those numbers. And for Heidi, if we avoid this final velocity, we end up with x final equals x initial plus the velocity initial of Heidi times the change in time for Heidi. Having the deltas really is important here. Plus 1/2 of the acceleration of Heidi times the change in the time for Heidi, again, squared. Don't forget that squared. Same final velocities. Same final positions, not velocities. No. Same final positions. So I can set those equal to each other and then solve for time. So I'm going to do that. I know that xf equals xf. So I can put an equal sign in there. So I'm going to make these two. I got xi for Heidi, which is same for everybody. For Micah. Velocity for Micah. Change in time for Micah. It's going to equal x initial for Heidi plus velocity initial for Heidi. Change in time for Heidi plus 1/2 the acceleration for Heidi. The change in time for Heidi squared. Now a lot of things go away. So these xi's, I call that 0. So they can go away because they're both 0. This term here, velocity initial of Heidi, that is 0. So that term disappears because there's a 0 in there. And now I'm going to rewrite this, and I'm going to substitute in for the delta times in the same place. And I'm going to start putting numbers in. So I might doing two things at once, so be careful. Velocity of Micah is 0.32. 0.32. The delta time for Micah is TF. TF. That's going to equal 1/2 the acceleration for Heidi, and everything's to the right, so everything's positive. The acceleration's 0.81. Time for Heidi is this term. That's a little messy. So there. Now that foils out, physics is done. Now you can do a bunch of algebra. If you rearrange this, you end up with the following quadratic doing algebra. You got to FOIL this. You got to move all the TFs to the same side. Take care of that. You get that 0 is equal to 0.405 t squared, t final squared, minus 1.292 t final, plus 0.5832. And I'm pretty sure that's what that all works out to be. Now, if you have a calculator, you have an app. So who has a knife? Can I borrow your calculator, Sarah? Calculator courtesy of Sarah Slotnick. Well, that's going to be on YouTube. I'll cut that out. Do not show. Do you want me to? I'm not going to show that again. All right. If you go to apps, hit the apps button. Apps is right there. You get all this, and you go down to number 9 there for her. Plismult2. You hit enter. This is a Pauli root finder and a simultaneous equation solver. Pretty powerful stuff. Pauli root finder is what we're going to do. It's quadratic. That means it's to the root 2, order 2. Now here's the tricky part. It says next right there. You got to hit the graph button for that. Next. There's my polynomial. I got to plug in these values. My first coefficient is 0.405. Enter. Then I'm going to subtract a 1.292. Enter. Then I'm going to add, that's right, move over, a 0.5832. 0.5832. Enter. And then I'm going to hit solve. It says solve right there, which means the graph button. Solve. Boop. We're done. Saved you like 10 minutes of aggravation using the quadratic formula. Now one of those times doesn't make sense. The one time says 0.5 seconds. Heidi hasn't even moved until 1.2. Remember, this TF, that's the time since Micah passed Heidi. Our 0 time was when Micah was at Heidi. So this says they would be together at half a second and 2.64. Well, the half doesn't make sense. That would make sense if Heidi was moving all the time and had been like moving backwards and accelerating forward. So she would have gone back and forward. But she's not. So that doesn't make sense. So the answer is the 2.645. We get a time 2.646. But it's 2 significant digits, so we get a time of 2.6 seconds for our answer. And there we go. Now to find the distance, we would take that time and put it back into the equation for Micah and find out how far Micah went. And if you do that, you get 0.85 meters. And that again comes from x final equals x initial plus velocity of Micah, change in time of Micah. All right. Make sure you have an app like that. You will have to solve quadratic formulas on your test. So, thank you very much. Hope you enjoyed today's video. 15 minutes.